What? Why is that still there? Okay. So this is our warm-up. We're on 1B. We're finishing an example of quadratic formula. A is 3, B is -1, and C is -6. So tell me how I start this out. Opposite of B would be 1 plus or minus the square root of -1 quantity squared, which is going to become 1, minus, and then there's a 4 that's part of the formula, times A, which is 3, times C, which is -6. Now, are we going to get a negative number?
Yeah.
Over 2A, which is 2 times 3. Because this is a -4 and a -6 back here, when we multiply, it's going to be plus, right? So 4 times 3 is 12, times 6, I don't know. What's 12 times 6?
76.
Plus 1 is 73. Okay, so 1 plus or minus the square root of 73 over what? Okay, can I do anything with that? You could separate it and rewrite it. But I don't think anything else. 73 is not divisible by anything. Okay? Everybody all right? All right, the discriminant is what we use to predict whether we're going to have, if we didn't want to do the whole quadratic formula, the discriminant helps us predict whether there's going to be 0, 1, or 2 solutions. When we have the quadratic formula, okay, it's -b plus or minus some square root, right, over 2a. What's underneath that square root? Can I take the square root of a positive number? Yes, so I get plus or minus some number, right? A plus solution and a minus solution. But can I square root 0? Can I square root 0?
0 times.
Yeah, I just get 0, right? So if what's underneath here was 0, when I went to add or subtract it, it wouldn't matter. I would just have the opposite of b over 2a. Okay? If b squared minus 4ac is negative, what happens? We have imaginary numbers or no real solution. Okay? So the discriminant is what's underneath the radical, b squared minus 4ac. And there are 3 possibilities. If it's positive or greater than 0, well, how many solutions will we have? Negative b plus or minus the square root of 7 over 4. 2 real solutions, right? Okay. If b squared minus 4ac is exactly 0, then we'll have just negative b over 2a, because this part would become 0. So there will only be 1 solution. If b squared minus 4ac has a negative value, okay, so b squared minus 4ac is less than 0, then what happens? So you end up with, say, -6 plus or minus the square root of -11 over 4. Do you have real solutions? No, you have imaginary ones. So you have no real solutions. Okay, you have non-real numbers or imaginary numbers. That's what we're going to talk a little bit more about today. The other option is this that I wrote down here. If it's greater than 0, there are 2 real solutions. Now, tell me, what is the discriminant again? Because it's going to ask that on the quiz. The formula for the discriminant is?
B squared minus negative.
It is the b squared minus 4ac part. It does not include the square root. Is everybody good? So, what is the discriminant for this problem? We do negative 5 squared minus 4 times 2 times 1. Anybody know what we get? Calculator does.
You get a number greater than 0.
What number do you get? Because it's going to ask on the quiz for you to find the discriminant. That's supposed to be a D. And you get 17, which is greater than 0. So what does that mean? Okay, 2 real solutions. All right, for number 19, opposite of B would be, wait a minute, we're not doing the whole quadratic. Erase that from your mind. B squared would be negative 5 squared minus 4A, which is negative 3, times C, which is negative 10. That's a lot of negatives. It is going to be a negative 25 minus 120, negative 95. Anybody? Yeah. Negative 95. So that means you would have no real solutions, or eventually we're going to say that's too complex solutions. Either one is fine. You can say no real, or you can say too complex. I don't care. No real is fine. All right, the last one, number 20, B squared would be what? B squared minus 4 times A, which is 4, times C, which is 1, would be 16 minus 16, so D is 0. When D is exactly 0, there is 1 real solution. Well, my tablet's working better. I still have really messy work all over the place there, though. Everybody okay? So last question on these notes. Determine the value, the nature of the roots. So if we just use the discriminant, we'd have B squared minus 4AC, which would be 144 minus 18 times 2 is 36, 72, 144. Is it 0, guys? Did I do it right?
0.
So what does that mean? A unique real solution. Okay? Questions about discriminant or quadratic formula or anything we did yesterday? All right, what we're going to move on to real quick now that I don't have pulled open yet, unfortunately, I don't think, are worksheet 3. Is it 3? Yes, thank you. I'm going to talk briefly today about imaginary numbers. You've all done this before. I got some bad news for you, though. This next quiz is no graphing calculator. So that you can't put your calculator in A plus BI form, I need you to understand how to do those without cheating on the calculator. And because I don't want you to have a program for the quadratic formula, I want you to be able to show me that you know how to do the quadratic formula. So you'll be able to use a scientific calculator, but not a graphing calculator. Does that make sense?
So like the science.
Yes. The ones you use for science will be fine. I will also get a hold of some of those so that we have some here if you need to borrow one, if you don't have one. Okay? Any questions? But that's the next quiz. So do not practice using quadratic formula program or using A plus BI mode on these calculators, because that's not how it's going to work.
Wait, how do you do it in
Under mode, it says A plus BI mode, and then you can type things in and it will give you answers. Some things the calculator will not do anyway, like powers of I that we're going to talk about Monday. All right, we're going to take the pretest today. Does anybody have a question about the pretest? Hey, does a pretest go in your grade? Does the pretest count on your grade? No. Does a pretest go in Skyward at all? No. Okay. But the pretest is part. Did I just say that out loud? Is part of your final. Okay? So you're going to see this as a post-test later, and it will be part of your final. So take some time today looking over the questions. Attempt any of them that you want, but the rest of the time today will be work time. All right, eventually you're going to have 3 standards that you have to know about complex numbers, how to add and subtract them, rationalize, and find powers of I. I'm going to cover this one today because it's real basic. I'm going to talk a little bit about this one, and we're going to say powers of I for Monday because I promised, and I'm going to skip distance and midpoint, skip powers of I. I'm going to go down here. When you add and subtract or multiply complex numbers, okay, a complex number is anything that can be written like this, which means it has a real part and an imaginary part. Because it has that I. And what is the definition of I? Anybody remember? What is the definition of I? The square root of -1. Very good. I is the square root of -1. Okay? But when you have to add or subtract things with imaginary numbers, complex numbers, okay, you just treat I as a variable. So for this example, what would you do? It is an adding example, not a multiplying example. So add like terms and we get what? The real part plus the real part adds up to 3. The imaginary part plus the imaginary part adds up to 1I. Or you could just write it as 3 plus I. Any questions on adding complex numbers? We added 5 and -2, and we added -3 and +4. You good?
Yeah.
Okay, next question has a subtraction in the middle. So, again, just solve it as though it were a variable. So distribute the negative. Don't forget that that negative applies to both of those things. So now I combine the real parts and get -4. And the imaginary parts and get +4I. Everybody good? All right. The only other thing I want to talk about today real quick is multiplying and maybe one dividing problem. This is 3B. When you multiply again, you treat them as a variable until the very end of the problem. Because when you get an I squared, if I is the square root of -1, when I square both sides, I just get... So we do that at the end of the problem, right? At the very end, we'll replace any I squareds with a -1. All right, so if I FOIL this out, or double distribute, 2 times 7 is 14. 2 times -4 is -8I. -3I times 7 is -21I. -3I times -4I is positive, because it was negative times a negative, and then it's a 12I squared. Now, I'm going to show a lot of work on this one. I would not normally show, but we're going to combine those like terms to get 29I. And back here, this is going to be a plus 12, but the I squared gets replaced as a -1. So then what? Yeah, that's -12. And this 14 up here can combine and become what? Just 2 minus 29I. All right, so this is a complex number where the real part is 2 and the imaginary part is -29I. All right, this is a really important example, and we'll talk about that as we get to the end of it, because what happens when I FOIL this together? 4 times 4 is 4 times -5I is -20I. Middle term times middle term is plus 20I. And 5i times negative 5i is negative 25i squared. So I have 16. What happens to the i's here in the middle? They cancel out. And back here I have a minus 25 that's times an I squared, which is a negative 1. So that becomes 16 plus 25, or 41. Okay, so what happened is two complex numbers multiplied together and became a real solution, or a real number. Whack. Okay. The reason that works has to do with the fact that these two numbers are what are called conjugates. And we are going to use that to our advantage. Conjugates are when you have a plus bi, like 4 plus 5i, the conjugate is a minus bi, or 4 minus 5i. When you just change the sign in the middle, these are conjugates. Okay? A plus bi, a minus bi. Those are conjugates. Everybody got that? So they're called complex conjugates. And I'm just going to do this first example and be done for today, in case anybody wants to get to these on their homework this weekend. This says 5 minus 3i is divided by, is that what it says? 1 minus 2i. Now, the problem is that weird mathematician who keeps throwing rules at us. I means square root of negative 1. Can you have a square root in the denominator according to him? No. So we have to get rid of it. Well, what did we just do that helped us get rid of an imaginary number and make it real? We multiplied by the conjugate. Remember when we did the conjugates, it came out real. So we need to make the denominator real. So what is the conjugate of that denominator? 1 plus 2i. And how are we actually allowed to multiply randomly by 1 plus 2i? Well, there's not an other side, but if we do it to the top, why is that okay? 1 plus 2i over 1 plus 2i is really just a form of 1. Does that make sense why it's okay to do it now? All right, so we got to distribute on the top and distribute on the bottom. Last example of the day. 5 times 1 is 5. 5 times 2i is plus 10i. Negative 3i times 1 would be negative 3i. Negative 3i times positive 2i would be minus 6i squared. Super careful on these, right? That you don't lose a variable, that you don't make a sign mistake. Okay, the denominator, 1 times 1 is 1. 1 times 2i is plus 2i. Negative 2i times 1 is negative 2i. Negative 2i times positive 2i would be negative 4i squared. Okay. Do you want me to rewrite it replacing I squared with a negative 1, or do you get what happens? What is negative 6i squared going to become? Negative 6 times negative 1 would make it positive 6. So I'm going to cross that out, and that's going to become a plus 6. And down in the denominator, a minus 4i squared would be negative 4 times negative 1, or positive 4. Now, if I combine like terms up top, I have a 5 and a 6 is 11, and a 10i minus 3i would be a positive 7i. Everybody okay with where I got those numbers or not? 5 and 6 were like terms, and then in the middle here, that was 7i. You good now? Down on the bottom, there was a 1 and a 4, which is 5. What else? Those two canceled each other out. That was the whole point. That's why it became real. Okay, I would let you leave this way. The directions will say write in a plus bi form. So your calculator if you were using your calculator or your math book, would write this because they would separate the A and the B. Does that make sense, guys? I'm okay if you left it. As long as you got rid of the imaginary part, I'm good. All right. Before I quit, these problems in, I can't remember which ones, 11 through 25, maybe, are the ones you can be working on tonight if you want to get started on that. Otherwise, just be working on page 2, the evens. Is that right? Page 2, the evens. Did everybody pick the homework checkup on the way in? Oh, yeah. I don't care. You want to write them on the back of it?
Yeah.
Here's the issue, guys, and I'm leaving this on recording. Can you open your book real quick and find these problems? Because they are not on page 8. They're in chapter 0, page P8. Okay, it's before page 8. Can you find P8? Okay, so if you want to take a picture of P8 right now, so that you don't have to get your book out again, the homework is going to be on P8. All right, turning the recording off. Oh,